Good afternoon, everyone. So, I am one of the TA for this course. So, before starting, I would like to have a brief introduction of all the participants. So, can you please just unmute yourself and give a brief introduction from which college or company or anything you belong in, from which state, and what is your name? So, please one by one unmute yourself and please introduce yourself. So, can I request Pallavi Rom to please unmute yourself and just give a brief introduction about yourself?
Hello, ma'am.
Hi.
Myself, Pallavi Ram. I am from West Bengal and I am pursuing now BTech in Heritage Institute of Technology and in second year. And so I joined this class today.
So, what is
Thank you.
your branch in engineering?
Yes, ma'am. My branch is chemical engineering.
Okay, you are from chemical engineering. Okay. So, I guess the other participants have left. I don't know why. Okay, no problem. So, let's start. Let me first share my screen. So, Vasant, can you please unmute yourself and please introduce yourself? Okay. Josephine, can you please give a brief introduction about yourself? Okay. I think there is some connection issue or what, I don't know. Athira NS, can you hear me?
Ma'am, hello. Yes, ma'am.
Please introduce yourself.
Ma'am, I am Adira NS. I am from Kerala. I am studying St. Joseph's College in Yalagoda in Thrissur district. I am doing my PG in MSc Chemistry.
Okay, so you are from chemistry background.
Yes, ma'am.
Okay, thank you so much. So I
Thank you, ma'am.
thank you. Josephine and Vasant. I don't know whether they are able to hear me.
Hello, ma'am.
Hi. Hi,
Uh,
Josephine.
can you hear me?
Yeah, I can hear you.
Okay, ma'am. I have some net issues. That's why I can't answer last
That's
question.
fine. Okay. So please
Okay,
introduce yourself.
myself.
Uh-huh.
Okay, myself, Josephine Jose. I'm studying in St. Joseph College in Nalakuda. I'm doing my master's in chemistry, and I'm from Kerala, Thrissur district.
Okay, okay. So people are from chemistry or chemical engineering background. Okay, but
Chemistry.
okay, you're from chemistry. Okay, okay. Okay, thank you so much. So what we will do, we will just discuss, I will give you a brief introduction of what was taught in the previous week module, and then we can begin with the previous year quiz questions. So if you have any doubt, you can ask me, or if you have question problem with the quiz or something like this, so we can discuss that. But for the quiz questions, we will discuss after the submission of the quiz. So let me go in slideshow. So this is waste to energy conversion course. The course instructor is Professor P. Mondal from Department of Chemical Engineering, IIT Roorkee. And I am one of the TA for this course. So I think my problem solving session is on Saturday from 3 to 5 p.m. So every week we will meet on Saturday from 3 to 5 p.m. and I am a PhD scholar in Civil Engineering Department at IIT Kanpur. So let me just go to the next slide. So, first of all, why it is necessary to convert the waste into energy? So, first and foremost thing is sustainable development. So, we need to develop, but it should be sustainable. That not environment is harmed, not any people or their beliefs is harmed, and also we are developing in terms of economy and all, but our environment is not harmed. So, if we see waste, so it can be classified on the basis of from which source is coming out, from what is its property, whether it is biodegradable or not, or whether it is coming from industry, then it will be industrial waste. If it is coming from agricultural activities, then it will be agricultural waste, and if it is coming from municipality, then it will be municipal solid waste. Also, we can classify the waste based upon its composition, whether it is organic or whether it is recyclable or whether it is inert. Neither recyclable or not the organics that it is can be degraded or can be biodegraded, or it can be used for any other purpose. So if we see the waste, so it can be based on the phase. It can be of three types: solid waste, liquid waste, or gaseous waste. So if we see energy conversion from waste, we will basically see solid and liquid waste, because the waste energy from gaseous waste is not that much developed, because it is very difficult to capture or store the gaseous products. So this entire course is about energy conversion from solid waste and liquid waste. So, if we see the solid waste, it will be either municipal solid waste or waste coming out from any industry or waste from any agricultural activity. Broadly, we can classify the solid waste in these. And if we see the liquid waste, then also it can be coming out from our houses, like the wastewater which comes out from our houses are known as sewage, or it can be coming out from any industry. So, based on the source from where the wastewater is coming, its property will be different. If it is coming from a paper industry, so the properties of the wastewater will depend upon that. It will be rich in carbon and other things. And if it is coming from sugar industry, it will be very rich in glucose and fructose and all. So also the leachate is which when on any landfill, when water falls in it, then it percolates through the pores in the waste and takes out the dissolve or suspended waste to it, and it comes out from the landfill, and it is known as leachate. So also we will see how some of the routes for the management of these waste. So this was all taught in the week 1. So sorry. So here are two pie charts which shows the composition of municipal waste in US and the composition of municipal solid waste in India. So if we compare these two, so we can see that in our country, the proportion of biodegradable waste is around 50%. And if we compare it with US, we can see that the composition of organic, or we can say the food waste is mainly biodegradable. It is around 21%. So there is a very huge difference between the composition of municipal solid waste depending upon depending upon whether the country is developing or developed. So in our country, which is a developing country, majority of the income of a person is spent in collecting of food and in food expenses. And if and in US we see that the percentage of food waste is very less, because majority of the food items which they consume, it is in the form of packaging. So lot of paper, board and plastic waste is very high in developed countries as compared to the developing ones. So next, so the first the module starts with introduction about why we need to convert the waste into energy. So I told that we need to convert because of the sustainable development. Second is, if we are converting the waste into energy, then that energy which we are getting the waste, it could have been extracted from the virgin material. So we are also conserving our resources, and also we will get rid of the waste, because after conversion the volume or toxicity of the waste will reduce. Also, since we are dealing with waste, there will be lot of risk associated. We have to see whether the waste is toxic. We have to handle it carefully, and if it is waste is hazardous, then we have to follow the rules for that hazardous waste management, and based on that we can extract energy from it. So, characterization of solid waste, if we see, for characterizing solid or liquid waste, we can characterize in terms of physical and chemical properties, and in liquid waste, we can one additional properties come, that is biological properties. So, if we see the physical properties of solid waste, it includes four properties. First is density, next is particle size distribution, hydraulic conductivity, and moisture content. So, let's move to the chemical properties of solid waste. It consists of proximate analysis. I think my slide just doesn't change. Is my second slide visible? Like slide naming title with characterization of solid waste.
No, ma'am.
Okay, so let me figure out this. Okay, now it's visible. So if we see the characterization of solid waste, we have seen the physical properties. Next is the chemical properties. So first chemical property is proximate analysis. In proximate analysis, we find out the moisture, which is find out by drying the waste at 105 degrees centigrade until constant weight is achieved, or volatile, which can be done at 950 degrees centigrade for I think 7 or 8 minutes in oxygen free condition in muffle furnace. Or next is ash percentage, and finally finding the fixed carbon, which is find out by subtracting moisture, volatile, and ash percentages from 100%. Next is the ultimate analysis, or also it is known as elemental analysis, in which we find out carbon, hydrogen, nitrogen, and carbon, hydrogen, nitrogen, oxygen, and also we can also find out sulfur by using ultimate analysis. Next is fusing point of ash, and for agricultural products we need to do the cellulosic composition. Next property is leaching property. If suppose if a waste consists of heavy metals, then we have to see that if we are extracting energy from that, what are the how much heavy metals will be leached in the water phase, how much it will come in the air phase, whether it is hazardous or not. We have to see all those. And finally, it is the energy content or the heating value, which is found out by bomb calorimetric experiment. So next is characterization of wastewater. So in wastewater, we see three properties: physical, chemical, and biological. So first one is physical. We find out the solids content, total solids, total dissolved solid, or total suspended solid. Next is the temperature. Generally, in our country, depending upon the weather, the temperature will be around 20-30 degrees centigrade if it is in summers, or lesser in winters. Next is taste, odor, and color. If we see the chemical properties of wastewater, we see hardness. Next is biochemical oxygen demand or chemical oxygen demand. In nutrients, we mainly see nitrogen and phosphorus. Since it is a wastewater, it will contain heavy metals and other salts like calcium carbonate and all. And next is total organic carbon and dissolved oxygen. Also, dew is very important, because if we are discharging the wastewater into some surface water, then for survival of fishes, the dew should not be less than 4 ppm. So for disposal of wastewater, DO is very important. Next is the biological. So in biological properties, we generally see the pathogens. If the obviously the wastewater will have pathogens, but after treatment, we see the amount of or concentration of pathogens by doing the MPN test, MPN or other biological test, and then the wastewater is discharged. So these were, I think, also there was some data based on or comparison based on I think Poland, Bangladesh. Some data was given about the municipal solid waste. You can go and go through the module. Also, I'll request you all to please before attending the problem solving session, just go through the module so that you will have the idea of what was taught and you can try to solve the questions. So I think on in this session we will discuss two assignment questions. Our first assignment is a very general assignment. It is one word answers, and then in the second assignment there will be I think one or two numerical or three, and then we will finish for today. So I will show you the question. I'll give you 2 to 3 minutes depending upon the whether the question is lengthy or it is a short one word question, and then you all please write your answers in the chat box, which of the option is correct, and then we will discuss whether it was correct or not. So the first question is ICPMS stands for. The options are integrated carbon plasma mass spectrometry, integrated coupled plasma mass spectrometry, or inductively coupled plasma mass spectrometry. So ICPM is a very good instrument for measuring metals, especially heavy metals at low concentration. So you have to find out what is the full form for ICPMS. So I'll give you all 3 minutes. Just take your time and write the option in the chat box. So the correct answer is C. So I got 3C and 1B. Okay. Again, it was C. So the correct answer is C. ICP-MS stands for inductively coupled plasma mass spectrometry. So the next question is, which one is not biodegradable? Paper, cotton, glass, tree trimmings. So it is a very straightforward question. So I'll give you all 2 minutes. Please write your answers in the chat box. So glass is the correct answer. Paper, cotton, and tree trimmings, all these are biodegradable because it contains biodegradable carbon. But glass is not biodegradable. So let's move to the next question. Sorry. Okay. So I got all C. So let's move to the next question. Moisture and ash content of an municipal solid waste is determined by proximate analysis, chemical analysis, ultimate analysis, or COD and BOD. So I'll give you all 3 minutes. Just take your time and write your answer in the chat box. So the correct answer is A, proximate analysis. It is used to find out moisture and ash content of municipal solid waste. Chemical analysis is a broader category for proximate and ultimate analysis. And ultimate analysis is the elemental analysis, that is CHNS, and COD and BOD are used to find out the organic carbon content in the wastewater. So let's move to the next question. So question is, bacterial infection in living system cannot be directly induced from air pollution, water pollution, soil pollution, or noise pollution. So it is also a very straightforward question. So I'll give you all 2 minutes. Just take your time and write the correct answer in the chat box. So it's obvious that the correct answer is noise pollution, because air, water, and soil, we can't come in physical contact of these and we can get the infection from the microorganisms. But the noise is something we can sense it. It is not it is not a physical quantity. So D is the correct answer. So let's move to the next question. So it is a numerical. We have to find out the stoichiometric air required to combust methane. So methane is CH4. We have to find out how much amount or in grams of air is required to combust per gram of methane. So I'll give you all 6 minutes. Please try to solve this question and write the correct option which you are getting. So we have to find out the stoichiometric air required to combust methane. So first we have to start by writing the equation for combustion of methane. So in combustion, methane will combine with oxygen and nitrogen to form CO2 and others. So please try to solve this and write the correct answer in the chat box. Okay, let's see how to solve this question. So I got four answers as D. So D is the correct answer. So if we have to find out the amount of air, so air consists of approximately 21% oxygen and 79% other gases, mainly nitrogen. So we will assume the air to be consisting of 21% oxygen and 79% nitrogen. And if we write the equation for combustion of methane, that is CH4 plus O2, but we have to find out the amount of air that is required. So air will have both oxygen and nitrogen. And if we see this relation that out of 100%, 21% is oxygen and 79% of nitrogen. So we can find out that each mole of oxygen is accompanied by 79 by 21 moles of nitrogen, and after calculating we will get say 3.76 moles of nitrogen. So if we write the combustion equation, so we have O2 plus 3.76 moles of nitrogen. This is our air. It will react, combust to give us CO2 plus H2O plus N2. Now we have to balance this equation. So after balancing, we will get 2 here. So 2H2O, 3.76 into 2, 7.52 moles of N2. So from this reaction, we can see that 1 mole of methane requires 2 mole of oxygen and 7.52 moles of nitrogen. So 1 mole of methane will be, so molecular mass of methane is carbon 12 plus 4 hydrogen. So 4 into 1, that is 16 gram. So for 16 grams of methane, we require 3 into 32 grams of oxygen and 7.52 into 2 into 14 grams of grams of nitrogen. So for 1 gram of methane, we will require 2 into 32. So I think I should write on the next slide. Okay. So for 1 gram of methane, we require 2 into 32 grams of oxygen plus 7.52 into 2 into 14 into 2, 28 grams. So this much of air, because air is consisting of oxygen and nitrogen. So we will add these, divide by 16. So after solving this, we will get 17.16 gram of air per gram of methane. So this is a question based on stoichiometry. After balancing of the chemical reaction, we can find out how much of oxygen or how much of air or nitrogen we require to combust 1 gram of methane. So let's move to the next question. Next question is, which routes have relatively slower rate of energy production from waste? Biomass, the waste here is biomass and municipal solid waste material. So the routes are biological routes, thermochemical routes, chemical routes, and the last option is none of these. So I'll give you all 2 minutes. Just take your time and write the correct answer in the chat box. So the correct answer is A, biological roots, because in biological roots we generally use microorganisms for energy production by either anaerobic digestion or by using composting. So these microorganisms have some inherent activity or growth rate, so they cannot exceed that, and also biological roots depends on many other existing character parameters like what is the pH, what is temperature, carbon content, and others. So biological root will give us relatively slower rate of energy production as compared to thermochemical and chemical roots. So let's move to the next question. So question is, during heating value calculation of a waste material, high heating value and HHV and GCV termed are used. HHV and GCV stand for. So the options are HHV is for high heating value and gross calorific value, or high heating value and gross carbon value, high heating value and green calorific value. So I'll give you all 2 minutes. Just take your time and write your option in the chat box. So the correct answer is HHV stands for high heating value and GGC stand for gross calorific value. So let's move to next question. So the question is, from the following flow diagram, identify the process. So we have this flow diagram. Waste goes to reactor with endothermic reaction and give us product. So we have to find out which of the following is the process which is shown in the figure. Either it is pyrolysis or gasification or incineration. So again I will give you 2 minutes. Just write your answer in the chat box. So the correct answer is A, pyrolysis, because in pyrolysis it is an endothermic reaction because we have to give some energy for the pyrolysis to take place, and through pyrolysis and pyrolysis is generally done in absence of air, and gasification is done in partial presence of air, that is oxygen, and incineration is the complete combustion of anything, so it takes place in presence of air. So the correct answer is A, pyrolysis. So next question is, what chemical reaction makes biodiesel? So options are trans-esterification, sublimation, polymerization, or fermentation. So just write your answer in the chat box and we'll see which of the following are correct. So the correct answer is A, through trans-esterification. This is the chemical reaction which makes biodiesel. So let's move to the next question. So this is the last question for this assignment. The question is, waste can be classified on the basis of source and usability, compostability, combustibility, and biodegradability, or all of these. So just write your answers in the chat box. So the correct answer is all of these, that is D, because waste can be classified on the base of source, from where it is generated, whether it is compostable or biodegradable or not, or whether it is combustible or not. So let's move to the next assignment. So this assignment is based on the module 1. So the question first is, the desirable characteristic of solid waste for higher energy production is A, carbon content, hydrogen content, heating value, or all of the above. So just write your answer in the chat box. So the correct answer is D. So I get 2D and 1A. So all of the above is the correct answer. So for getting higher energy, the carbon content should be high and hydrogen content should be high, and also of course the heating value of the waste should be high. So let's move to the next question. Gasification and pyrolysis process for energy production from biomass and waste are associated with thermochemical conversion, biological conversion, chemical conversion, or D, physical conversion. So please write your answers in the chat box. So the correct answer is A, thermochemical conversion, because energy is provided for the in the gasification and pyrolysis process for the process to take place. So next question is, which of the following density excludes the volume of pores and interparticle spaces? A, apparent density, envelope density, absolute density, or bulk density? So I'll give you all 1 minute. So please write your answer in the chat box. So the correct answer is C, absolute density, because it excludes the volume of pore and interparticle spaces, and in other apparent and bulk density, the volume of pore and interparticle space is included. So in bulk density, volume of pore and interparticle spaces both are included, and in apparent density, volume of pores is included but interparticle space is excluded. So let's move to the next question. So we have to identify the apparatus in the figure below. So this is the apparatus. We have to find out whether it is a distillation column, sieve analyzer, ball mill, or none of the above. So I'll give you all 1 minute. Just write your answer in the chat box. So the correct answer is B. It is a sieve analyzer. It is used to determine the particle size. So next question is, so we have to find out the missing step in the following depiction of ultimate analysis. So sample carrier gas, it is combusted, then it gives A, then it mixing is done, then B, and then finally detection. So the options are A is separation or reduction. So we have to find out what is A and B, either separation or reduction, separation, reduction and separation, drying and reduction, and last separation and drying. So just write your answers in the chat box. So the correct answer is B, that in ultimate analysis after combustion, reduction is done, and after mixing, separation of the gases is done. So let's move to the next question. So the question is ultimate analysis of coal determines a dash content. So whether it is carbon, hydrogen, nitrogen, sulfur, or carbon, ash, sulfur and nitrogen, carbon, sulfur, volatile matter and ash, or carbon, volatile matter, ash and moisture. So I'll give you all 1 or 2 minutes. Just write your answer in the chat box and we'll move to the next question. So the correct answer is A. Through ultimate analysis, we find out C, H, N, and S element, that is carbon, hydrogen, nitrogen, and sulfur. So let's move to the next question. So question is in proximate analysis, moisture percentage is measured by drying the sample at dash degree for 24 hours. So we have to find out the temperature at which the sample is dried for finding out the moisture content. So please write your answers in the chat box. So the correct option is C for determination of moisture content in sample. We dry the samples at 105 degrees centigrade for 24 hours. So the next question is Wrinkler's method is used for the measurement of pH, conductivity, dissolved oxygen, or none of these. So please write your answers in the chat box. So the correct answer is dissolved oxygen. Wrinkler's test is used to find out the dissolved oxygen content. However, for pH and conductivity, you use the pH and conductivity electrode. So let's move to the next question. Which analytical instrument is used for the measurement of trace metals in the solution? First is AAS, Atomic Absorption Spectrophotometer, Turbidity Meter, pH meter, or Conductivity Meter. So please write your answers in the chat box. So the correct answer is A, that trace metals are found using AAS. So let's move to the next question. So it is a numerical type question. We have to find out, I think, the gross heating value of the waste. So the question is, a solid waste with 1% sulfur is composted in a bomb calorimeter. The temperature of the bucket water increases from 26 degree to 28 degree. The water equivalent of the calorimeter is 2402 calorie per degree. 1 gram sample is used for the test and par 45C10 wire is used for ignition. Out of the 10 centimeter wire, 2.6 centimeter is unused. To titrate the calorimeter washing, 24.2 ml of this much normal sodium carbonate is required. Calculate the gross heating value of the waste. Consider the thermometers are working perfectly. So four options are given. The whole statement is given. We have to find out the gross heating value of the waste. So I'll provide you the formula and then so gross heating value is calculated using this formula where Hg is the gross heating value, m is the mass of the sample in gram, W is the energy equivalent of calorimeter in calories per degree Celsius, T is the net corrected temperature rise in degree, and rest is E1, E2, E3, where E1 is correction for heat of formation of nitric acid, E2 is correction in calories for heat of formation of sulfuric acid, and E3 is correction in calories for heat of combustion of fused wire. So everything is given. We have to find out what is E1, E2, E3, and then we are using the given formula we can find out the gross heating value. So I'll give you all 5 minutes. Just take your time and try to solve this question and write the option which you are getting in the chat box. So I got one answer as C. Let's see what is the correct answer. So temperature is given as 26 degree. Final temperature is given as 28 degree. So temperature rises 28 minus 26, that is 2 degrees Celsius. Again, amount of, I think, so C1 is alkali is 24.2 ml. So C1 is 24.2 ml. So E1 will be amount of alkali used is 24.2 ml. C2, so sulfur percentage is 1%. So E2 is calculated as 13.7 into Ct, C2 that is sulfur content into M that is mass of the sample used. So it will be, we have 13.7 into 1% sulfur into 1 gram of the sample used, that will be 13.7 calorie. So E1 will also be in calorie, not in ml. And we have C3 that is amount of wire that is used. So we were having, I think, 10 centimeter of wire and 2.6 was, I guess, used or left. So 2.6 centimeter is unused. So the amount of wire which is used is 10 minus 2.6. That will be 7.4 centimeter. And so E3 is calculated as 2.3 into, why it is writing so small, into 7.4, that is 17.02 calorie. And W was given as 2402 calorie per degree centigrade. So the gross heating value will be 2 into 2402 minus 24.2, that is E1, minus E2 13.7 minus E3 17.02 divided by amount of sample taken, that is 1. So after calculating this, we will get 4749.08 calorie per gram. So this is the gross heating value of the sample which was taken. So the gross heating value is 4749. So the correct answer is C. So these were the questions. in the first module, so we'll try to solve the previous year quiz questions on next Saturday from 3 to 5 p.m. So I'll request you all to just go through the weekly lecture content and try to solve the questions. And if you have any problem with the material or the questions, we can discuss in the next problem solving session. So if you have any doubt, you can ask me, or otherwise we can end the class here. So if anyone have any doubt, so I think that you all have no doubt. So thank you so much for joining, and I will encourage you all to please join the problem solving session every week. I think it is on Tuesday and Saturday. So please join the sessions. It will be very helpful for you in solving the questions. So thank you so much for joining. Have a nice day.